In this video, we're talking about a question from the Spring Release 2018 questions from the Geometry End of Course Assessment in Ohio. Question 10 is the focus of this video, and we're talking about a proof here dealing with a parallelogram. So we have in this proof, it says, a parallelogram and incomplete proof are shown. It says, given information, W, X, Y, Z is a parallelogram. So that's some information that I could, if I were you, again, you have a screen with this question, I would draw this picture and then label it like I'm doing now. So we know definition of parallelogram states that the opposite sides are parallel. So I'm going to just put those markings on there. And then it says we're going to prove that WX segment, WX up here, and YZ down here are congruent. Nice thing is we have this drag and drop option, and part of it's already filled in. So again, go ahead and do a sketch of this proof on your scrap paper. It'll help you think through it. We have in this first statement line that the WXYZ is a parallelogram from our given information. And then just like we marked in the picture, segment WX is parallel to segment YZ. WX and YZ are parallel, that's what we marked. And then the next statement is WZ and XY are parallel. We marked those sides parallel. And that is the definition of parallelogram. The next statement that we're guided to says that the angle ZWY, so I'm going to mark that right here, and angle XYW, so XYW is down here, are congruent. What's the reason for that? Well, we've, up to this point, just stated that we have this pair of parallel lines, and this line right here, we call it transversal. And so our parallel lines cut by a transversal have special properties. So we know that these two angles are congruent by alternate interior angles theorem, which is listed right here. So I would drag and drop that into spot 3. I'm just going to write it in, alternate interior angles theorem. So my next statement says WY is congruent to WY. Now that one is an easy one. That's the reflexive property. WY, so that's this segment right here, is congruent to itself, right? Oh, we didn't take a closer look. ZYW, ZYW, and XWY are also congruent to one another. This will be important in the next step to make sure we marked all these pieces. Same thing, alternate interior angle theorem. But back to the reflexive property. WY is congruent to WY. Anything we have to state where something is equal to or congruent to itself, we use that reflexive property. And then number 5, we've got these two triangles are congruent to one another. So that's the WYZ triangle, WYZ, this one down here, and the YWX, this triangle up here. And what is the theorem that allows me to say that? So we've got several options. Angle, so we have an angle here, a side, and another angle. Angle, side, angle. So the correct answer would be angle, side, angle. Remember, we need 3 pieces for congruent. Sometimes we can use 2 pieces for similarity, but not for congruence. Now finally, I should remind you of your proofs booklet that you did. Our last step is proving what we set out to prove, that WX is congruent to YZ. So how can we say that? We just proved that the two triangles were congruent. WX is congruent to YZ because corresponding parts of congruent triangles are congruent. corresponding parts of congruent triangles are congruent. Now this one will throw you. Corresponding parts of congruent triangles are similar. Don't get thrown off. Read carefully. So we also abbreviate that as CPCTC. And that is our proof of this parallelogram and corresponding parts being congruent.